Hello and welcome, my dear students, to my new video for grade 9 students. And this is covering important questions. Some of them I have taken from the file that has come for your end of term important questions, and some of them are queries and questions by my students, their doubts before their final exam. So let's go on into the video and see what questions we are covering today. So this video is made exclusively for all my grade 9 students which are going to give the exam tomorrow for math. So it's a revision guide which is going to be very helpful for understanding some important questions that will help you for tomorrow's exam, along with covering the queries and questions that some of my students have asked me. So let's get into the video. And if you are new to my channel, please don't forget to like, share and subscribe if you're finding my videos useful in your revision for maths exam. First question that I've been explaining you that I've selected is from end behavior of graphs of function. We are going to be covering questions 1 to 9 on page 455 of your math book. So let's understand what is this end behavior. The girls whom I have taught, they actually know about end behavior, but I'm going to repeat here for all my other viewers and new subscribers. So look at end behavior. It is the behavior of a graph, as the name suggests, behavior of the graph towards the endpoints, right? So as x approaches positive or negative infinity, how is the graph behaving? So let's recall a little bit about directions and signs that are going to help us. So these are the two axes that you know. The horizontal is your x-axis, the vertical is your y-axis. As we move towards the right side of the x-axis, we have plus sign, positive numbers, left side, negative numbers. As we go up, it is positive. As we go down, it is negative. This is our origin, 0, 0. Right? So you are going to predict actually the behavior of the graph towards the left and the right. So as x is going on the left means as x is decreasing, how is the graph behaving? If your graph is fx, how is it behaving? Is it increasing or decreasing? That's what is end behavior on the left. Or you could say it in infinity form, that as x is going to negative infinity, where is fx going? That's what you need to predict on the left side of the end behavior. So how the graph is going to behave at the left end point will come and tell you the answer here. And for the right, as x is going to plus infinity, where is fx going? Is it going to plus infinity or minus infinity? That's what you need to say. So as x is increasing, how is your fx behaving? Is it increasing? Is it decreasing? It depends upon the graph which is given, and we'll use the graph, as you will see in the questions to come, to predict end behavior. Okay, so I've already explained you the same thing. It's written here that the values of x are increasing towards plus infinity, denoted by this arrow. And on the left hand, when the x values are decreasing towards negative infinity, it is denoted in this way. And the function is taken as fx. If it is increasing, it is going up. So just like left and right, you have the two directions: up, which is positive y-axis, so plus, and down, which is negative y-axis, so negative sign. So accordingly, we'll see how the sign becomes for end behavior. Let's get into some questions. These are questions 6 to 8 that I've selected. Here the graph is given by the blue color. So this is a linear graph. You can all see this is non-linear, again non-linear and linear. So quite clear. Now whether you get in your exam linear or non-linear doesn't matter. In every case you could easily determine the end behavior. So I'm going to be taking here question 6 and okay, I'll take question 7. So these are going to be classwork that we'll discuss in the session right now. And then 8 and 9 you can try yourself. I'm sure you'll all be doing correctly once you understand the video really well. Okay, so question 6, on the left and on the right. These are the two directions we are looking for. So on the left, this is negative side, positive, positive, up, negative, down. So let's see, as x is on the left, so two ways of writing end behavior. I'm going to write both for you. One is in terms of increase, decrease. So as x decreases, because it is negative side, we are going on the left side, y or fx is going down. Can you see it's going down? So it's also decreasing. So, or second way, as x goes to negative infinity, y also goes to negative infinity. Both are decreasing. Very well. You can see here. Let's come on right. So, as x is increasing means positive side. Where is y going? Up, up and up. So, it is also positive. Or in terms of infinity, as x goes to plus infinity. Why I say plus? Because it's on the right. Y also goes to plus infinity. So that was your end behavior for question 6, which was a linear graph. Why? Because graph was straight line. Quite easy. Let's talk about question 7. Now this is a curve. You can see it's going up, down, like that. It's not a straight line anymore. So it's a non-linear one. So on the left, let's talk about left. As x goes to negative infinity, graph is going down, so y also goes to negative infinity. On the right also it's going down, so as x goes to plus infinity, y also goes down, so minus infinity. Both sides that you can see it is decreasing. So now you check your answers for questions 6 to 9. Okay, so I'm again taking some more questions from the topic of exponential equations. These are going to be those questions where we solve the exponential equations using power property of equality. So in case you have forgotten, this is going to be a good revision for you. Again, these are important questions taken from your math book, page 621. So if you want to refer to them, these are questions 16 to 25. We are going to be taking some parts out of it so that you are able to solve similar questions for your exam. So my student had asked me, Mahara from grade 9, this question. So definitely I'm going to pick that one for you, and we'll take one more which is, say, this one. So 16 and 17 are similar. I'll do 16 for you. You try 17. 18 is also similar. 19 is a little tricky. I'll do for you. If you want, I'll take one more, and all of them are going to be exactly based on solving with the same trick, that is power property of equality. So what is this power property of equality and how does it help us to solve exponential equation? That's a learning objective for this slide. So I'm going to do here first question 16 for you. Pay attention how I'm going to solve. First I write the same equation which is given. And in this, if you see, this is an exponential form with base 2 power 5x. This is exponential form base 8 power 2x minus 5. So first we need to make the powers equal. Now which is smaller out of the two, 2 or 8? Definitely 2. So I can reduce my 8 with the same base. Remember, in order to apply power property of equality for exponential equations, the base has to be same. So if base is same for the two exponents, the power property says the powers will also be equal. Okay, so that's what we are going to be using here, power property of equality. So I can now write my 8 in terms of 2 as what? 2q. So I do that, 2x minus 4. So this is 2 times, now there are two powers. So again, exponent rule, powers of power. So when there are two powers, they are multiplied. So I'm going to now multiply. That's why I put these brackets. Now, are my bases equal? Oh yes, they are equal. So if bases are equal, the power property of equality can be applied. And it says if the exponent values are equal, the powers are equal as well. So 3 times this is equal. Now, how do you multiply? Which property? You'll distribute this 3. So 3 multiplied with 2 is 6x minus 4 with 3, 12. Amazing. Now I need x, so I'm going to definitely isolate it. Let me take this 5x here. It changes sign. Let me take this negative 12 on the other side. It changes sign as well. So 12 is equal to x. That's my answer. That's what we wanted. The value of x. We wanted to solve for x. So khalas, that's the solution. Okay, so that was easy, question 16. Now let's go on for another one. This is answer number 19 that now we are doing. This is the doubt of Mahara, so let's do it for her. So 1 by 2. Now here it is a tricky situation because you have a fraction here and you have 16 here. So we don't have any bases equal. How we apply this property? By making the base same. So how we make them same? Here it is 16, here it is 1 by 2. That means 2 is below. So if I take this 2 above, I can write it with a negative power, 2 to the power negative 1. Correct? So this is 2 to the power negative 1, and in case you are confused how I got this, then you may write like this: 2 to the power 0 is 1, 2 to the power 1 is 2. So I have divided, so power will subtract and it will be written as 0 minus 1. Same thing, whichever you find easy. Now here again 16 is a big number. I have to make base equal, so I can write 2 to the power 4. If you don't know how to write 16 equal to 2 to the power 4 without using a calculator, the hint is do the factorization or the find prime factors of 16. So if you multiply 2 with 2 with 2 with 2, that is done 4 times. What you get is 2 to the power 4. That's why this thing. Okay, now we have same basis. 2 powers, 4x multiplied, and they are equal. So 4x is equal to negative 1, or x is negative 1 by 4. So x has a negative value. Okay, and now you can check your answers here. So we had done 16, we got x as 12, which is correct. And we had done 19, so it is negative 1 by 4, correct. So that's how you solve. I hope, Mahara, you understood your question, how you can solve using exponent property. Okay, now on this slide you have a question which is again a part of the important questions given to you from page 563 of your book, question 7 to 12. Now this question clearly mentions to use a graphing calculator. However, in your exams you're not allowed to use a calculator, so I will give you an alternative. Those of you who have studied from me in grade 9, they know that we have done another method of solving these kind of absolute value equations. These are absolute value equations. They have absolute value function inside them. And in order to solve them, we can also do by an alternative where we need not use a graphing calculator. And that method is solving absolute value equations by using the graph. So you can draw your graph using X and Y table, and in case you have forgotten that, I will quickly revise for you that method, and that is what you will see now in the next slide. So let's revise. So this is the key concept that I'm now going to be revising for you, which talks about solving an absolute value equation by the method of graphing. Now in this, we are going to graph the graph of the related function. Okay, so what is that and how do we find it? Let's revise and recall. Okay, so I'm going to write here and highlight a few important things. This is an alternative method and you don't require a calculator. Okay, so all those questions, if you get in your exam, you can solve them without the calculator using this technique. So in order to draw the graph of a related function, you will solve the absolute value equation and confirm how many points that graph is meeting your x-axis. So if the graph of the absolute value function intersects or meets the x-axis at one point like this, so it will have one solution. If it meets at 2 points, it is going to have two solutions. So these are the two solutions, the 2 points, 1 point, and sometimes it may not meet x-axis at all. In that case, there is no solution or zero solution. So what is the important point you should remember? The point is that the number of times the graph intersects the x-axis is telling you the number of solutions, and that's a very important point that you need to keep in mind. So let's see an example how we can apply this method and get our solution. Okay, so this is the absolute value equation. As you all can see, it has an absolute value function. So in case you have forgotten these two bars, if you have a variable inside, like here you have 2x plus 6, this is an absolute value function. And when I say solve this absolute value function, I mean that I need the value of the variable in it. So I need what are the values for x. So step 1, you will find the related function, and step 2, you will graph it. So looking at your related function, you will decide what are the roots. Now let me talk a little bit about relative functions. This is what I'm going to repeat and revise for the girls or the boys who have not who do not remember its meaning. So related function, always remember, has one side equal to 0. So on the right, something, whatever function you have, on the right it has to be 0. So here you have a lot of function, but on the right you don't have a 0, you have 5. So how can you get rid of the 0? Let's think a little bit on that line. So if I want to make this right side equal to 0, that means I'm going to subtract 5 on both sides, right? And when I do that, 5 and 5 is gone. It is colors from both sides. So what you're left with, only 2x plus 6 equal to 0. And yes, now you have the right side as 0. So this is your correct related function. Now this related function is important in the sense that the number of times the graph of this related function will meet the x-axis, exactly those will be the solutions for this given equation. So let's go to step 2 and now find the graph. Okay, so this is the correct solution where you get the related function. We have already discussed about it. So it is this function fx equal to absolute value of 2x plus 6. Now, if you remember and recall from our previous sessions, the graph of absolute value is always a V-shaped graph. Okay, now this V-shaped graph, in order to draw it without a calculator, you need the table of values. So you are going to make XY table or X and Fx table. Now here you can take at least 5 points. Some we can take positive, some negative, and one definitely can be taken as 0. So here if you see the table of values, there are so many points taken. But yes, 5 points are good enough to draw the graph. Take 5 values of x, correspondingly plug them in the function of x, get your fx values, and remember the basic definition of an absolute value function. I'm repeating in case you have forgotten. Anything that comes inside the absolute value function will always give you a result which is positive. So even if you plug in a negative value, let's take -5 and plug in inside. I will just show you for this point how you evaluate. So 2, where there is x, you are going to put this value that you're taking. So -5 plus 6, absolute value. How much is this? -10 plus 6, again absolute value, and it is absolute value of 5. Now, absolute value cannot be negative. So we've done a quick change here. 10, -10 plus 6. So you are going to subtract. So -4. Now -4 in itself has a negative sign, but because of absolute value, you know whatever is the number inside, positive or negative, result is always positive. So that's why you get 4. So what is the point? -5, 4. So I go on the x, 1, 2, 3, 4, 5, -5. On the y, 1, 2, 3, 4. This is the point, right? So -1, -2, -3, -4, -5, this point, 5 times up, and 1, 2, 3, 4, 4 times here. So this is 4. Yes, this is the point. Now you similarly join all other dots, join them, and then you get the graph. So now tell me, what is the solution? Quite easy to identify. How many times it is meeting? So when it meets the x-axis, means we are talking about the x-intercept. So y is going to be 0, and that's what you see for this value. So the solution is x equal to -3. And it's just 1 point, so it is going to be one unique solution. So I hope you have recalled and revised about absolute value function, how to do the related function and the graph. So you can use this process in case you're not allowed to use a graphing calculator. In the last slide, we saw how absolute value equation can be solved in a very similar value. In a similar way, absolute value inequality can also be solved. And when I talk about inequality, they can be greater than, equal to, less than, equal to, greater than strictly, or less than. So any which one which is given to you, you can do it by graphing by following the same method, that is finding the related function or the related equation. Here the symbol is less than equal to. It indicates that the solution set consists of the x values where the graph lies below the x-axis because it is less than equal to. And therefore we'll look at the x-intercepts as well. So when we do the related function, it's already having right side 0. So we just take the function given here fx. This is your fx, and now step 2 we do the graph. So we'll go ahead and make table of values for this given function and then see what are the solution that we get. We'll connect the dots and then we'll get our graph. Okay, so in a similar way here, you have got the graph as a V-shaped. We have followed the same method. We have drawn the table of values. So they've taken so many points, but as I told you, 5 points are more than enough. And then you just look at the intercepts. What are the 2 points? So there are, here you see 2 points, right? So you are going to definitely get an interval. What is this point? It comes from the table also. One is this, another is this. So the intercepts are at 1 and 5. Now if we go back a little to the question, the inequality was less than equal to. So if equal to is there, we'll have closed dot, means the endpoints are included. So x equal to 1 and x equal to 5 are going to be a part of the solution set. And because the inequality is less than equal to, so all the points of x which are between 1 and 5. So x equal to 1, x equal to 5, this orange line in between denotes the solution set. So this is how you do the graph. And similar question was asked by my student Haraba from grade 9. So here I'm making this video for you. Session for today for grade 9. I hope you find the video useful. Don't forget to like, share and subscribe to my channel if you haven't done that till now. And here's Mr. Chika wishing you all very best for tomorrow's exam. Do well, read the question properly, don't do any sort of silly mistake, and most of the times the answer is in the question. So read the question nicely and do your question in a smart way. Make sure that if you feel that there's a question that you feel stuck on, you don't spend too much time, not more than 3 minutes on each question, so that you complete the entire paper. First do the questions that you're confident of, and after you finish doing those, you move on to the ones that you feel stuck. You come back to them again, and before you submit your exam, make sure you revise. Keep last 5 minutes for revision of all the questions. All the very best. Bye for now.